Okay, so 8.6, we're basically talking about what you would do to graph and look at the solutions for polynomial inequalities. And so we kind of talked about what polynomial inequalities are before. First thing is an inequality is just something that has a greater than or less than sign in it, right? So we're not really changing things up a lot, but we've added this either greater than or less than sign right here. And sometimes an equal to part, greater than or equal to or less than and equal to. And we'll talk about what that means in just a minute. But here's some examples of what polynomial inequalities look like. Negative 2x to the fourth minus x squared minus 2 is greater than 4. 3/4 x plus 6 is less than or equal to 0. And 8x to the third plus 2x squared is less than 6x plus 5. Okay, so basically they're just what we've been, they're polynomials, just like what we've been working with, except for now we've added that less than or greater than sign in there. Okay, so here are some steps to solve a polynomial inequality. So if you get stuck, you can always go back and look at these. We're going to work several problems using these steps. Step number 1 is to find an equivalent inequality with the polynomial on one side and 0 on the other side. Okay, so basically we're doing the same thing we've always done. We're solving these for 0. That's the first step. The second step is we're going to solve the related polynomial equation, that is solve for f of x is equal to 0. Okay, and I think I can say this until I'm blue in the face, but that means that we are finding the zeros. That is the whole goal here. We're finding the zeros. So we can either do that by factoring, or we can use our calculator, that quad program, most of the time to find the zeros. We're going to use the solutions to divide the x-axis into intervals. So once we find the zeros, we're going to divide the x-axis into intervals that contain those zeros. Then we're going to select a test value from each interval and determine the polynomial sign on the interval. This little section right here will make a lot more sense once we work a couple of examples. Number 4, determine the intervals for which the inequality is satisfied and write interval notation or set builder notation for the solution set. If the inequality has the equal to part, then you're going to include the endpoints in the intervals. In other words, it's going to get a bracket instead of a parenthesis. So let's go through some problems and kind of go through these steps so you'll know what to do here. So the first one says solve x squared minus 3x minus 4 is greater than 0. So step 1 was to get it equal to 0. And that one was already equal to 0. We already had the polynomial on one side and 0 on the other side of the inequality. This is 8.6. The next step was find the x-intercepts. So remember, another name for x-intercepts are the zeros or the roots. We have several ways that we can find zeros or roots of x squared minus 3x minus 4. What's one way we can do it? If I said find the zeros, what would you do right now? Synthetic division. You could if you knew what to start dividing by. This is, you can just use your quad program in the calculator, right? That's what finds zeros. That's what we've been doing. Yes, absolutely. Or if you don't have a quad program in your calculator, the next step would be to factor it. Okay, so you don't have a quad program, so we're doing it the old school way. We would factor it and we would say, what multiplies to -4 and adds to -3? Okay, so something that multiplies to -4 and adds to -3 would be x minus 4, x plus 1. -4 times 1 is -4. -4 plus 1 is -3. And we've talked about kind of the steps to do that before, but this, when you get the answers to this, when you set them both equal to 0, that gives you your zeros. And if we had a plugged in our calculator in the quad program that A was 1, B is -3, and C is -4, we would have gotten these same answers. This should be a +4, sorry. So our zeros are X could be equal to 4 and X could be equal to -1. Those are zeros. Those are our X intercepts. Is everybody okay with that part? So the first step was to set this thing equal to 0. If it wasn't equal to 0, you had to get it equal to 0. The next step was to find the zeros. After you do that, you're going to use those zeros to divide this thing into intervals. So the first 0 that I would come to on the number line would be -1. -1 is smaller than 4. So my first interval would be from -infinity to -1. I want to kind of look and see what's happening there from -infinity to -1. Then I want to look from -1 to 4. That would be my next 0. And then I'm going to look from 4 to infinity and see what's happening there. Okay. Now, I'm going to go back to the whole goal of this thing is at the very beginning of the problem, where it says that we want this function or this polynomial x squared minus 3x minus 4. We're looking for wherever it is greater than 0. That's what this says. So we really are focused on where this whole thing is greater than 0. So this graph for you right here, and if you kind of look at the graph of this, and you look at your x-axis wherever, and remember the x-axis is the same thing for y is equal to 0 as your x-axis. So all of these things at the bottom of the graph, right down here at the bottom, these things, let me put this in a different color, these things down here would all be less than 0. Okay. And these things up here at the top of your graph, and I'm showing you this because you can kind of see the answers on your graph. All these things would be greater than 0. And the things that are actually on the line would be equal to 0, right? So keeping this in mind, I want the solutions to be things that are greater than 0. So I only want the part of my graph that is on top of the x-axis. So this little section down here, the section that goes from -1 to 4, it looks like it's all less than 0. Do you agree with that? So that wouldn't be part of my solution. So I'm already gonna commit to this right now that this part right here is a no. Because I'm looking at my graph and I can see that I'm looking for the x's that are, let me rephrase that. I'm not looking for x's that are, I'm looking for y's that are. So let me erase this. I'm looking for parts of my graph that are greater than 0. You can also, so if you can't see that on your graph, you can also use this test value thing. So during on the test value, what you're going to do is you're going to pick a number. You're going to pick any number that you can think of that's between -infinity and -1. So we could pick -2 because that is in between -infinity and -1. Okay, then you're going to want to pick a point between -1 and 4. So we could pick 2. We could pick any number between -infinity and 4. And then we might want to pick, or we also want to pick a number that is between 4 and infinity, maybe 5. Okay, it just can be any number that is between those. Now, I need to find out what the values of this polynomial, x squared minus 3x minus 4, for -2, 2, and 5. So I could go in and individually plug it in and say, okay, the first one I'm looking for is -2. So I could do -2 squared minus 3 times -2 minus 4, right? Every time I see an x, I could plug in -2 and I could hit enter and it would tell me the answer. But I have to do 3 of these and I don't want to have to do that every time. What's an easy way that I could do this? How can I use my graphing calculator here to help me? You go to y equals, I heard it right. We can go to y equals. That would be the easiest way. And then we could look at our table and our table will tell us the answers. Okay, so if we go to our graphing calculator, we go to y equals and we type in x squared minus 3x minus 4. It's going to do that math for me. So when I go to second graph to look at my table, I'm wanting to know what -2 is. It looks like it's 6. We also have +2, which looks like it's -6. And we said 5, and I'm going to have to scroll down to get to 5. But 5 is +6. Okay, so I just jotted down my points there. So I'm going to go back. We're going to write these down. So we came up with 6, -6, and 6 for those values. Okay. Now remember that we said that the answer has to be where these things are greater than 0. So 6, things that are greater than 0 are positive, right? So this one would be good. This one would be good. This is not good, right? So that's why we said that based on our graph, we didn't think it was going to work either, because all of these answers in this interval were negative. They were below the x-axis. So the answer is we're good from -infinity. They're going to be positive answers from -infinity to -1, and then again from 4 to infinity. Those were the intervals that worked. The interval in the middle gave us negative numbers that were not greater than 0, so that interval does not work. Okay. The last thing we want to do was at step 4, and it's not written down. And step 4 has to do with if your inequality has the equal to part. In other words, does it have that line underneath it? And it doesn't. Because if it had the line underneath it, we might have to change some of these to brackets because they could be equal to 0. But it's not. There's not an equal to part here. So we will work some examples where you'll see that. But for right now, we're going to skip over step 4 because we don't have the equal to part. Okay, questions? Okay, so step 1. We have an inequality. The first thing that we need to do to our inequality is we need to get it where one side is equal to 0. And right now, that's not the case. So I need to start working on this thing and maybe subtract an x from both sides of my inequality. That would give me x squared plus 2x minus 5 is less than or equal to 3. Then I would subtract 3 from both sides of my inequality. That's going to get me x squared plus 2x minus 8 is less than or equal to 0, which is what I want. After you get your inequality with one side equal to 0, you can move to the second step, which is find the zeros of x squared plus 2x minus 8 is equal to 0. And right now, we really have 2 ways to do that. We can use our calculator, which we talked about using the quad program and plugging in our A, B, and C that way. And we can find our zeros that way. That would be perfectly fine. Or we can factor this. We can think of things that multiply to -8, but add to 2. If you use your quad program, you don't have to do this. It just gives you the answer. So I think x plus 4, x minus 2, because 4 times -2 is -8, but 4 plus -2 is 2. So to get the zeros, we would solve this. Set them both equal to 0, and then we're going to solve x is equal to -4 when we subtract 4 from both sides, and x is equal to 2 when we add 2 to both sides. So those are our zeros. Step 3 is to divide this and make this table. And so we wanted a test point. We want to look at the sign of this thing, but we need to divide this in intervals. So you're going to decide which one comes first. Does -4 or 2 come first? Absolutely, -4 comes first. So you're going to say, my first interval I'm going to look at is -∞ to -4. Then I'm going to look at an interval from -4 to the next test point, or the next 0, which is 2. And then I'm going to look at 2 to infinity. So it doesn't really matter what test points you pick here. To pick a point from -∞ to -4, I picked -6. I had to pick a point that was included in this -4 to 2. I picked -1. And then from 2 to infinity, I picked 3. Because I'm going to go ahead and say, I'm going to go ahead and write the answer. I'm not going to tell you what the answer is. I'm just jotting down what we're kind of looking for, because right here we said, when we got this with 0 on one side, we said we're looking for things that are less than or equal to 0. Right? That's what I want to kind of keep in mind. I'm looking for things that are going to give me answers that are less than or equal to 0. What kind of numbers are less than or equal to 0? Negative. So we're looking for negative. So those are going to be below the x-axis, right? So we're kind of looking at, when we're doing this, we're looking for what interval is going to be below the x-axis. So I'm going to go to my graphing calculator. I'm going to look at y equals. I'm going to type in what we had. So x squared plus 2x, and then -8. I'm going to go ahead and graph that. Okay, just so I can kind of keep in mind. Now, if I'm looking for things that are less than the x-axis or y equals 0, then my answer should be this interval from here to here. Y'all agree? Because those are the things that are down here at the bottom. If it wasn't from here to here, it's up here at the top. So if you're not able to see that on your graph, that's okay, because you can always use your test points to tell what the answer is, but you can kind of check yourself on your graph and go, which part of this graph is negative? What's the part underneath the x-axis? So this interval from, it looks like -4 to 2. So the next thing I'm going to do is I'm going to go to my table and I'm going to write down the points. We said -6. So -6 gives us a point of, or gives us an answer of 16. -1 was -9, and 3 is 7. So going to jot down, we got 16, -9, and 7. And we want the things that are negative, right? 16 is not negative. 7 is not negative. So we were correct when we looked at our graph and said, okay, the answer is this interval from -4 to 2. Now, step 4, don't forget step 4. Step 4 says, go back and look and see if your sign has an equal to part in it. Does it have the equal to part? Yes. If it has the equal to part, then that means it could be on the actual line. It could be equal to 0. So that means that we're not going to put parentheses around our interval. We're going to put brackets because it could be equal to, because it has the equal to part. Okay. We okay with that part? I like this next one that you can kind of already see because it's already equal to 0. We already have 0 on one side, so I don't have to do any work on step 1. I'm just gonna write step 1 and put a check that it's done. You good? Are you sure?
Yes.
Okay. So I'm just gonna check, it's done. We're good to go with that one. The step 2 part says, okay, well, tell me what the zeros are. So can I use the quad program on this one to get my zeros? Yeah, what would A be on this one? -1, because the thing that's in front of the x squared is a negative, right? So it would be -1. B would be what's in front of x, and we don't have any x's, so B would be 0 here, right? And C would be 7. So you absolutely could use your quad program to come up with your zeros. You could also solve it. So I'm going to go ahead and solve it because it's not too bad to do that. So -x² is equal to -7. Then I would want to multiply both sides by a -1 or divide by -1 to get rid of that negative. So x² is equal to 7. We need to get rid of a squared, so we would take the square root. So it would be a positive or a negative square root of 7. We're fixing to have to come up with the interval here. And the square root of 7 is approximately, so you're going to kind of have to know what number around about 2.6. You could just type the square root of 7 in your calculator, because when you're doing the interval part, you're going to have to actually pick some numbers bigger or smaller than the square root of 7. And if you don't have any idea what the square root of 7 is, you're going to have issues with that. So the next thing I'm doing is dividing this up into some intervals. I want to pick some test points, and I'm going to look at the sign. So the smallest 0 I have is negative square root of 7. So I would want to look at a point from -infinity to negative square root of 7. Then I would want to look at negative square root of 7 to positive square root of 7. And then I want to look at positive square root of 7 to infinity. Okay. So I'm going to come down here and I'm going to go ahead and say, well, answer. Let's talk about what the answer. The answer is supposed to be something that is greater than 0. So we're talking about positive numbers. So when we look at our graph, we're really talking about things that are above the x-axis, above the line y = 0. So when I go to my graphing calculator, I should be able to kind of get an idea of what's happening here. When I go to y equals, now type in 7 minus x². Okay, I'm going to look at my graph. So I said I wanted things that were positive, so above the x-axis. So it would be this section in the middle, right? That would be above the x-axis. These are below, this part and this part is below the x-axis. They're going to be negative. So the next thing, we want to go back and look and come up with some, so we kind of think it's this middle section that's right. But those were above the x-axis. But we can come up with some points that kind of work here. Remember that we said the square root of 7 is around 2.6. So we need something that's smaller than -2.6. I picked -5. You could pick anything smaller than -2.6. Something in between the square root, negative square root of 7 and positive square root of 7, I picked 1. And then I picked +5 on this one. So we could go back to our table and get those answers. I'm going to save us a little bit of time and work here because I already came up with the answers we got. This one would have given you -18. This gives you 6, and this gave me -18. So were we right? Was it the middle section that gave us answers that were positive? Yep. This is not it because that's negative. This is not it. So we're ready for step 4, which is to write our answer. So you always want to go back and say on step 4, does this have the equal to part? It does not. It's just greater than. And if it's just greater than, you're going to leave it in parentheses. You're not going to put brackets because it's not equal to, it's just greater than. So negative square root of 7 to positive square root of 7 are going to be the answers that are going to produce a result that are greater than 0. Not bad, right? Okay. So here we go. This one's nice. Step 1's done. It's already solved for 0. So step 2 is to find the factors of 6x minus 9 minus x squared is equal to 0. Okay, so we could actually factor this one out if we wanted to. Those of you who are following on Zoom, I'm going to ask you, this one's a little bit tricky because we've got a negative in front of the x squared. Let's go ahead and go to our quad program and get the answers to this one. So what are our zeros? We're just going to use our quad program and cheat a little bit on this one. So A would be -1, B would be 6, and C would be -9. So if you're following along on Zoom, you're going to type what the zeros are in your chat. I'm going to go, while they're doing that, they haven't typed anything in. I'm going to go ahead and start making my table. It'll be ready for us if we need it. So this would be our test points, and this would be our sign, not toilet paper. I guess it's really making me think of toilet paper this time of year because it's Halloween, almost Halloween, and that's when people like to roll your yard and do egg and all that stuff. Okay, we have one person that has responded. 1 second. Okay. They are fixing to come up with our zeros. Have any of you guys come up with our zeros? What'd you get? So 1 0 at 3. That's weird, right? So what does the graph of that thing look like if it just has a 0 at 3? Let's go back and really quick say, we know that our answers, just before we start doing all this, we know that our answer is going to be things that are less than 0. So those are going to be negative. We're looking for things that are negative. Okay, I'm going to go to my graphing calculator and just eyeball what this thing to remind you guys of what this kind of looks like. So if I type in 6x minus 9 minus x squared. Okay, and hit graph. Well, now that makes sense to me, right? It just has one x-intercept because it only hits the graph once. And so, or only hits the graph, only hits the x-axis one time. So that would be one that has a multiplicity of 2. So 3 is a 0 with a multiplicity of 2 because it bounces off right there. It's tangent to the x-axis, which is what we've been talking about some. So yes. And then we said we wanted things that were less than 0. So if we draw a line straight across here and look at our x-axis where y is equal to 0, what things are going to be less than 0? Everything, right? Everything is less than 0, except for that one point right there that's going to give us issues. Because if we plug in a 3, that would actually give us 0. So 3 can't work because it's actually, if you plug in 3, you're going to get 0, but everything else works besides 3. So let's look at what we would do on the rest of this. So on this time, we only really need to look at 2 intervals. We need to look at the interval from -infinity to 3, and then we need to look at 3 to infinity. So we could pick some test values. We could pick, let's say, -infinity to 3. We could pick the number 2. From 3 to infinity, we could pick 4. So we would go back to our table and look at what's happening at 3 at 4. So at 3, it's 0. I'm sorry, we picked 2 and 4, didn't we? 2 is -1 and 4 is -1. So all of that stuff is, both of these intervals work, right? Before we write the answer, we need to go back and make sure that our inequality doesn't have the what sign. And it doesn't. So we can go ahead and write, okay, well, all of these things are negative except for 3, and it's not an answer because 3 makes this thing equal to 0, but everything else works. 3 is a problem. Okay. We have one more. This one is not so nice because it is not solved for 0 on one side. So I'm going to have to take care of that by subtracting 4x. So I would get x squared minus 4x plus 12 is less than 0. So now I've got 0 on one side of my inequality. Step number 2, I need to find the zeros of this function. So I want to think of things that multiply to -12 and add to -4. And there's just not. There's not anything that I can think of that multiplies to -12 and adds to -4. So let's go back to our quad program. So this must be one that maybe the solutions are imaginary or irrational. So I would plug in 1, -4, and -12 in my quad program to figure out what those zeros are. What? Yeah, it could be a positive or negative square root. That's irrational. Yes, it absolutely could. You're absolutely right. So doesn't come out pretty anyway. I mean, you could use the quadratic formula to figure those things out. And I'm saying I copied the problem wrong, right? X squared minus 4x plus 12, and then I changed it to a -12 right there. Sorry about that. I caught my mistake when I got normal answers there, but that should have been a +12. So I need to go back. Sorry about that. So we were looking for, and I don't know if I said this right a while ago, we were looking for something that was multiplied to -12 or +12 and adds to -4, and we couldn't think of anything. If I said multiplies to -12 and adds to -4, we could have thought of something, but I copied the problem down wrong. Sorry about that. So I'm getting, when I get my zeros in the calculator, 2 plus or minus 2i square root of 2. So I've got 2 zeros and there are 2 plus or minus 2i square root of 2. Bless you. So let's just think about this. If our zeros are both imaginary, are we going to be able to see them on a graph? They're not going to cross the x-axis. It's not going to work. Okay, so me making this table right here is not going to help with this problem. If I go in, let's just look at it real quick. So if we go and graph this, y equals x squared and minus 4x plus 12. And we hit graph. You can see that little part at the top. Okay, but it doesn't have any x-intercepts. All of the answers are positive or negative then. They're all above the x-axis, right? So that means all the answers have to be positive. We can find test points and things like that, but every answer is positive because they're all above the x-axis. So let's go back and look at what we're looking for. So I'm going to just kind of, on number 3, instead of drawing this table, I'm just going to kind of make me a graph of this thing and go, this is kind of what this thing looked like. Looks like all of my answers are positive. And we want, on the answer, we're looking for things that are less than 0. So we're looking for things that are negative. That's never going to happen because all the answers are positive. So we would say the 0, which is with a line through it, which means the null set, which means there's nothing that's going to make that negative. So that is an example of one that would happen that way. That you can't, it's not going to happen. What if it was the other way around? What if we were looking for things that were greater than 0? It would be from negative infinity to positive infinity. Everything would work, right? Would be greater than 0. Doesn't matter if our zeros are imaginary or not. Everything would be greater than 0. It would work. Okay. So that was 8.6. That was the very last section of this